All right, we're going to talk about using another form of quadratic functions called intercept form. But before we do that, let's review the other two types of forms, and then we'll have all three forms on one slide here. So the first one is standard form, and standard form, y equals ax squared plus bx plus c. One of the benefits of standard form is c is always your y-intercept. Okay. However, to find the 2 points we really, or the two things we really like, the vertex and the axis of symmetry, the AOS there. Axis of symmetry is x equals the opposite of b over 2a. And then knowing that point, that's actually the x value of our vertex, the opposite of b over 2a. And then the y value is f of the opposite of b over 2a. In other words, all this means right here is that, let's switch where we put that there. This just means substitute x value into function for the y value. Substitute x value in the function. Well, maybe we'll get rid of the for the y value. Okay, and that will give you your y value there. Vertex form. Vertex form is nice because it immediately tells you your vertex. Your vertex is HK. And then that means your axis of symmetry. Since your x value of your vertex is the same as your axis of symmetry, it's x equals h. In intercept form, this form allows you to quickly identify the x-intercepts. Okay, and I should really slow down and write that nicer. And x-intercepts where it crosses the x-axis. The axis of symmetry is also halfway between those x-intercepts. Those x-intercepts, by the way, are P and Q. Okay, so these are your x-intercepts. All right, and so it's halfway between the x-intercepts, halfway between P and Q. The A term has the same characteristics as it does a standard and vertex form. And so just a quick reminder, the A term tells us in all three forms, if A is positive, the parabola opens up. If A is negative, opens down. Okay, so we look like that or we look like that. All right, it also tells us when A is, I've used capital. Usually we use lowercase. I don't know why I use capitals this time, but when A is greater than 1, it's a vertical stretch. And when A is between 0 and 1, it's a vertical shrink. Okay. All right. Shrink just means it gets wider. Stretch means it's getting narrower. Okay. So let's go ahead and use the intercept form here. All right. When I look at this graph, it says graph y equals negative x minus 3 and x minus 7 times x minus 7. Notice this is a negative 1 there. My x-intercept, well, one of them is x minus 3. And the reason that's an x-intercept is because we set that equal to 0, we get x equals 3. That's an x-intercept. And then if we did the same thing over here with x minus 7 equals 0, right, we get x equals 7. And I just assumed you remembered the zero product property. It's when you say, okay, well, what if y equals 0? That means one of either negative 1, x minus 3, or x minus 7 has to equal 0. Obviously, negative 1 cannot be 0. But if x minus 3 equals 0, x is 3. And x minus 7 equals 0 when x is 7. So my x-intercepts are 3 and 7, meaning it crosses the x-axis at 3 and at 7. Well, you can find the axis of symmetry pretty easy by taking these two values, 3 plus 7, and adding them up and dividing by 2. Okay? that's going to give you your axis of symmetry. So x equals 3 plus 7 over 2, or 10 over 2, or 5. Even better, if you have a graph and you plotted your points, hey, your axis of symmetry is directly in between those points. It's halfway. In this case, x equals 5. So if you have the graph, it's really easy. It's just halfway between the points. Your vertex, well, your vertex is, we have to kind of calculate the vertex here, right? We know the x value is 5 because these are always the same. But the y value I have to calculate. And so you plug that 5 back in, or substitute it back in up there. So do f of 5 equals -1 times 5 minus 3 times 5 minus 7. So for those of you like, how's he getting that? I'm just putting 5 in here and here. Right? Okay, I'm showing my work. So that gives me -1 times 2 times -2, which ends up giving me a grand total of +4. So the y value is 4. Here we go, 5, 4. Notice this graph does open down because a was negative. You could plot some other points on here if you wanted, but usually when you're using an intercept form, just those 2 or those 3 points are fine. All right. If in my class we talk about the trick, if a, whatever a is, if you're at the vertex, if a is 1, you go over 1 and up 1. If a is -1, you go over 1 and down 1. That'll always give you your first point. So if you identify a, in this case a is -1, that tells you how much you go up or down based on going over 1 unit from the vertex. It only works for the first point, but hey, it gives you 2 more points. Okay. Is this a maximum or minimum? It is the vertex is a maximum. And it's a maximum at y equals, we use our vertical number line here, which we call the y-axis, at y equals 4. It's a maximum. It's increasing. Well, if you identify your axis of symmetry, x equals 5. If I was on the graph reading it from left to right, I'm going up over here. So I'm increasing on this side, and I start falling on this side of the axis of symmetry, so I'm decreasing over here. So I'm increasing when x is less than 5, and I'm decreasing when x is greater than 5. So increasing when x is less than 5, decreasing when x is greater than 5. It's always based on that number. So domain, well, domain has to do with my vertex. Okay, my domain is always all real numbers here. Sorry, the range has to do with my vertex. The range is, y is, and we have 4, it's always this value. And in this case, we're going down, so it's y is less than or equal to 4. So starting here, we're going downward. Okay, so you'll notice all these values, 5, 5, 4, 4, those are all from your vertex. That's why vertex is so important there. Okay, this symbol means all real numbers if you aren't familiar with that. All right, well, let's try another one here. Describe the domain and range of this graph. After you graph it here, f of x equals 2x squared minus 2. This is in standard form. I'm going to go ahead and try to put it in intercept form. It's harder to graph when it's in standard form. So intercept form, I am going to set f of x equal to 0. And I'm going to do some factoring. What goes into 2x squared and -2? Well, 2 does. 2 times what is x squared? Well, that's x squared. Or, sorry, 2 times what is 2x squared? That's x squared. And 2 times what is -2? It's -1. And then I look at this, and this is almost vertex form now. So I went from standard to almost vertex form. If that squared was out here, it would be vertex. So I'm really not in a form here. It'd be nice to get it to intercept. So I look at x squared minus 1, and I go, hey, that's a difference of 2 perfect squares. So if you remember your factoring rule, that's your plus-minus rule, right? Your x plus, x minus, or the square root of this, which is x, square root of this. Oops. X plus 1, x minus 1. So you now notice I'm in vertex form. The benefit, once again, of vertex form, what makes x plus 1 0? Well, x is -1. What makes x minus 1 equal 0? Well, x would have to be 1. So my x-intercepts, negative 1 and 1. So plus and minus 1, meaning here and here. So my axis of symmetry, well, that's halfway between those. So x is equal to, well, in this case, my axis halfway in between is x equals 0, right? That's 0, and I'd have to substitute 0 into, I could put it into either of these three equations. I'm going to use the top one, it's easier. So if I said, well, I want f of 0, well, that's 2 times 0 squared minus 2. And once again, if you're like, what is he doing here? I'm putting 0 in here and here, doing the math, right? So that is negative 2. If you recall graphing these, when you have ax squared minus c, really it just says, hey, I'm dropping my graph 2 units down. Well, I'm right here. All right. And you'll notice I go over 1 and up 2. That's my a term. That was a little trick I showed earlier, right? But anyway, there we got it. I'm going to go ahead and stop right after I get through that point. Okay. Domain and range, well, domain, all real numbers. It's going on forever. There's not a value of x that would not work in our equation. Our range says, where do you start on the y-axis? Well, I start at 2, and I'm going upwards. So y starts at 2, and it's going up, so it's greater than or equal to 2. So if you're in standard form, if you can factor it and get to intercept form, do it. It's a lot easier to graph. All right. So using the intercept to find zeros, we've kind of been doing this, but really this is just saying these x-intercepts are also called zeros of a function. They're called zeros. It's because when we call it a zero, we're saying f of x, this right here, is equal to 0. Okay, so we're saying x minus 3 and times x plus 8 equals 0. So one of these two things has to be 0. So if x minus 3 equals 0, x is 3. If x plus 8 equals 0, x equals negative 8. Okay, those are my two zeros there. If it's not in factored form, it's a lot harder to find the 0. So here I'd have to set this equal to 0. All right, I'd say that equals all of this stuff. And I'm in standard form. Try to factor it, you know. What goes into 3, 30, and 27? 3 does. 3 times x squared, 3 times 10x, and 3 times 9. And then factor this. Two things that multiply to make 10, multiply to make 9 and add to 10. Well, those two things happen to be 1 times 9. It becomes 3 times x plus 1 and x plus 9. All right? So here, x equals negative 1 and x equals negative 9. All right, try another one here where set this equal to 0. Hopefully you're pausing and trying these on your own. And it's always nice to have your a term be positive. So I'm going to try to take out a greatest common factor, which is negative 4 in this case. Negative 4 times what is negative 4x squared? Well, that's x squared. Negative 4 times what's negative 24? Well, that's positive 6x. Negative 4 times what is positive 28? Well, that's negative 7. And now I'm factoring. Two things that multiply to make negative 7 and add to 6. Well, that would be positive 7 and negative 1. So I end up with negative 4 times x plus 7 times x minus 1. Okay, well here, x equals negative 7. And here, x equals 1. All right. Well, that's nice because if you ever have to graph and you're in standard form and you want to go to vertex form, just like we did with that smaller equation, you can do that fairly easy by graphing the function or factoring the function first. So use the zeros to graph it, meaning you have to set this equal to 0 and factor first. So if I do that, I end up with 7 and negative 8 there. So That would be -1 times -7. So I get x minus 1 and x minus 7, which ends up giving me zeros of x equals +1 and x equals +7. Okay, so 1 and 7. Axis symmetry is halfway in between. So we get x equals 4. The vertex then is 4. Well, we substitute 4 in, so we do f of 4. 4 squared minus 8 times 4 plus 7. That's 16 minus 32 plus 7, which is -9. All right, and the y-intercept, actually, standard form is nice, y equals 7. So we can get an extra point out of this, and then we can reflect that extra point. 2, 3, 4. Okay. And if you remember my rule, a equals, in this case, 1. We go over 1 up 1. All right, so we have this graph that does something like that. And I knew I was going to have a hard time doing that. I'm going to add a weird angle here. There we go. There's our parabola. All right. Write a quadratic function in standard form whose graph satisfies the given conditions. Okay, standard form, and the vertex is -7, 5, meaning I am going to use vertex form. All right. So using vertex form, I need to know A, H, and K. Well, the conditions they give me, they say the vertex is -7, 5. That's my HK. And they don't tell me anything else. So really, that means A can, in this case, can be anything. It's up to us. So if I'm going to have to go to standard form, I'm just going to make A 1. So if they don't tell you what A is, make it whatever you want it to be. In this case, I'm going to go 1. That's going to give me y times 1, x minus -7. Right? H is -7. Notice it's -7, so it's minus, plus 5. K is 5. And so that gives me y is equal to, well, 1 times anything is itself, so I'll ignore the 1 there. That's a positive, 2 negatives. All right. Well, that's perfect if we wanted vertex form, but it says standard form. So let's go ahead and change that up to standard form here. So we'll have y equals x plus h, or excuse me, x plus 7 squared plus 5. And that's y equals x plus 7 times x plus 7 plus 5. All right, well, I can multiply that out. That gives me x squared plus 7x. Right, so x times x squared, x times 7 is 7x, and then 7 times x is another 7x. And 7 times 7 is 49. And then we have our plus 5. Combine like terms, x squared plus, well, 14x plus 54. We are now in standard form. Now, if you used a different a term, you'd have to put that a out in front here. Here's where your 1 is hanging out, right? And at this point right here, you'd have to distribute it to this whole thing if you use something other than 1. However, when you're multiplying by 1, nothing changes, so it doesn't matter. Well, let's write a quadratic function in standard form who satisfies these conditions. All right. In this case, we are going through -6, 0, 3, 0, and -4, 18. Well, anytime you see zeros in a coordinate, you should think intercept. In this case, they're y equals 0. So if y equals 0, this is your x-intercept, as is this. Oops. So 3 and -6 are my x-intercepts, meaning that's P and q. So I could use intercept form. A times x minus p and x minus q. All right. Well, we'll put our a there. I'm going to go ahead and x minus p is negative 6. And x minus q is 3. Okay, and so this becomes a positive because we have two negatives. Now, it also tells me another xy coordinate. And they don't give me anything about a, but they do say it's xy, so I have to use that for x and y. And when I substitute that in for x and y, just to show that it goes through that point, notice I'm left with a single variable. And that single variable is a. So if I do the math here, I can actually find a. I get a, that's 2, that's negative 7. So really I have I get 18 equals, well, 2 times negative 7 is negative 14a. So a is ugly. It's 18 over negative 14, which, by the way, is negative 9/7, right? And it doesn't matter where we put the negative. You put it on top, bottom, or right there in the middle. So you have this equation where you have y equals a negative 9/7 times x minus negative 6, or x plus 6, times x minus 3. That's really what you have if you use this point and you find a. And you have to put that in standard form. Okay, so I'm going to multiply this binomial times binomial. Okay, so I get x squared minus 3x, 6x, and minus 18. And all that times negative 9/7, which gives me negative 9/7 x squared. Negative 9 times negative 3 is positive 27. Okay, so those of you freaking out about that ugly fraction, you know, you're just multiplying numerators together. The denominator stays the same. Positive 27x. And then negative 9 times negative 18. Negative 9 times negative 18 is negative 162, or is positive 162, negative times negative. And then you just put a 7 on the bottom. You're now in standard form. All right. So if they give you another point, you have to find a. Up here, they didn't tell you what a was, and they didn't give you another point, so you're good to go. All right, the last thing in this lesson, they like to give us cubics, okay? And really it's because zeros kind of work with cubics, but a cubic is x to the third power. So graphing a cubic function. So using zeros. So really I want to set f of x equal to 0. I'm going to do everything the same I did before. It's just I have to factor this. It's going to be difference of two squares. That's our plus minus. X plus 2 and x minus 2. And notice I now have 3 sets, which gives me 3 x-intercepts. 6, negative 2, and 2. All right, so that means I'm at 6, and I'm going up by 2s here. It looks like 2, 4, 6. 2, and my negative 2. All right, and so if I put my function in this table down here, and I'm going to put the original, use the zeros and at least one point between each zero to graph the function, I'm going to put it in numerical order. So negative 2, I'll skip because I need a point in between. There's my 2 and my 6. And I know that when I put negative 2 in, I'm going to get 0. And I know when I put 2 in, I'm going to get 0. And when I put 6 in, I'm going to get 0. I know that because of up here. But in between negative 2 and 2, well, a point in between, an x value, would be like 0. When I put 0 in for x, 0 minus 6 is negative 6. 0 squared minus 4 is negative 4. And that gives me negative 6 times 4, or 24. Oops. Sorry about that. And so I get 0, 24. So 0, 24. And then, let's see, between 2 and 6, let's pick 4. Doesn't have to be exactly, but we'll use it. 4 minus 6 is 2. 4 squared is 16 minus 4 is 12. And, well, I actually get 24 again. So 4, oops, I think this was negative. Oh, that's negative 2 there. Okay, that's negative 24. 4, negative 24. Alright, so right there. So a cubic graph actually starts down here. It goes up, it turns. Whoa, alright, let's try that again. Sorry, I took my eye. Boy, I'm having a rough go there. Try this one more time here, I hope. There we go. It's quite the zigzag graph. I'm going to elaborate or exaggerate that a bit there, but okay. There we got it. A cubic starts low, ends high. My arrows go in up. Oh, wow. Holy moly, I am way sorry there. Well, this graph is starting to look a little better anyway. I'm afraid if I try to erase it, there we go. It starts low, ends high. It goes in opposite directions. That's a cubic. Now, it's not exact. It could do, we just picked a few points. If we want to be really precise, we pick all the points in between our zeros. All right. The last thing we can do is write a function using the zeros of a cubic. Okay. So we want the zeros of a cubic are negative 4, negative 2, and 3. The graph of the function passes through 5, 7. Write the function. So you're in y equals, using intercept form, it's the same, x minus p, x minus q, and we just add one more. It's like x minus pq r. All right? So that'd be like p, q, and r. There's just 3 sets. So y equals a times x minus negative 4. And x minus negative 2. And x minus 3. Right? Negative 4, negative 2, and 3. And it has to go through the point 5, 7. So that's an xy value. So that's going to help us with an a term here. So let's put that in. So 7 for y. Okay. I haven't used parentheses yet. I usually substitute in parentheses. A and 5 plus 4, right? 2 negatives. And 5 and 2 negatives plus 2 and 5 minus 3. So I get 7 equals a times 9 times 5 and 7 is, or 5 and 2 is 7. 5 minus 3 is 2. 9 times 7 times 2 is 126. So a is equal to 7 126. Oh, that's ugly. Which, by the way, reduces, if you want to, it's 1/18. All right. So we could write our function, f of x is equal to 1/18, that's my a, times x plus 4, right, my minus minus, x plus 2, and x minus 3. And notice it does not say go in standard form. So we are done. We can leave it in. Standard form would be a lot tougher with 3 there. Very good. Well, let's see. That's all I got for you. Good lucky.